This is part 2 of acid basis 1. If you notice the little guy right there, that means we're going to the exercise portion, and this is going to be the second part. All right, so first off, we have 2 of these. In these, what I would like you to do is identify the acids and bases and the conjugate pairs for the following. All right, so looking at this, we've got H2SO4 and water goes to H2SO4 negative plus H3O plus. So we got to find which one loses a hydrogen, which means it's the acid. So H2, H2, H3. So this loses. This has to be the acid because it donates, which means this is the base. So if this is the acid, its conjugate would be over here. The conjugate for the base, would be over here to that acid. Let's look down here. We've got ammonia and hydrofluoric acid goes to fluorine, goes to ammonium. So there's the H, and it's leaving this. So this has to be the acid with its conjugate base, which means this is the base with its conjugate acid. Right like that. Okay. Yes, you can do the arrows just like that. However, it's easiest for you. Okay, write the formula for the conjugate acid of each of the following. HSO3, H2O, HPO4, and HCO3. So, write the formula. What we're going to do to find the conjugate acid, we're going to assume these are bases. Bases accept the hydrogen, so you add a hydrogen to the structure. So what you would see is HSO3 would be H2SO3. H3O, which gives you a positive. H3PO4, negative, so that makes it a positive, cancels it out. H2CO3 cancels it out. Okay? So again, let's find the conjugate base. That means I'm getting rid of or losing a hydrogen. To find that, it donates. We assume these are acids, and it donates. So you got to get rid of one of the hydrogens. So we've got HSO3. Get rid of the hydrogen. You're going to make it more negative. So it's SO3 2 minus. Because there's already a minus. You got to minus another one because I'm getting rid of a proton, of a positive. H2O, I got to get rid of one of the hydrogens. That makes it negative. I would totally accept HO minus, although typically you want to do OH negative, okay? H2PO4, get rid of one of the plus. So I'm going to take away one of these and make it more negative. So there's a 2 minus to that one. All right, let's do this again. Take away the hydrogen. It's going to become one more negative. So CO3, 2 minus. Okay, amphoterism. Some substances can be an acid or a base, depending on the reaction. So we've got HSO4 plus H3O plus goes to HSO4. So in this case, this is positive. This is going to lose one. If it loses one, this gains it. So that gains it. This is my acid. That's my base. But in this one, if I've got H2O, it's going to become the base. When combined with a stronger acid, HSO4 will accept a proton base and be the base. But when mixed with a weaker acid, HSO4 will donate and become the acid. For a substance to be amphoteric, it must be able to be both donate and accept a proton. So what I would think is amphoteric would be water and ammonia. So let's look at, yes, we saw that right here. water, depending on what it's combined with or how it's put with it, will either be an acid or a base. All right, summary. Acid-base definitions and theories. So Arrhenius, a hydrogen producer, hydroxide producer for base. Bronsted, proton donor, base, proton acceptor. All right, so try and do the acid-bases definitions, finish up the worksheets, finish up anything extra with this. Make sure you get Pogles done. If you have any questions, please don't hesitate to ask. Hope you guys have a great day.